name is Dr. Shahinkar. I am here for presentation of the session 4 in Module 5 Computer Organization. The contents are hardware control overview, control unit organization and microprogram control unit. To execute the instruction, the processor must have some means of generating the control signals needed in the proper sequence. There are two categories in this. So hardware control or microprogram control. In hardware system, it can operate at high speed but with little flexibility because their connections are involved. Here you can see that the circuit hardware control circuit, it contains various digital circuits, control step counter, step decoder, encoder, instruction decoder, IR instruction register, input, and so on. Hardware control is a method of control unit design. The control signals are generated using logic circuits such as gates, flip-flops, decoders, etc. Decoder encoder block is combinational circuit. Decoder or encoder is a combinational circuit that generates required control outputs depending on the state of all its inputs. Instruction decoder, it decodes the instruction loaded into the IR register, instruction register. If IR is an 8-bit register, then instruction decoder generates 2 per 8, that is 256 lines, one for each instruction. Okay, so it consists of separate output lines. So you can see why so many lines are connected. If it's a 8-bit, 2 per 8, 256 lines will be used. It consists of separate output lines. INS1 through INSN. Instruction 1 to instruction M. For each machine instruction. It consists of separate, according to code in the IR, one of the output lines INS1 through INSN is set to 1 and all other lines are set to 0. It means what? One instruction is enabled at what time? One time. What is step decoder? Step decoder provides a separate signal line for each step step in the control sequence. For each step, T1 means step 1. Time inserted during the step 1. Encoder. Encoder, it gets the inputs from the instruction decoder, step decoder, external inputs and condition codes. Or from all these, once encoder accumulates all the inputs, it uses all these inputs to generate individual control signals. What is the output of the encoder? Individual control signals. Y in, PC out, add, end, so on. For example, if Zn is equals to T1 plus T6, add T4 BR. The signal is asserted during the T1 means the signal is asserted at the time slot 1. T6 means the signal is asserted at the time slot 6. What is advantage? What is the advantage of hardware control? The sequence of operations carried out by this machine is determined by wiring of logic. Wiring, what you can see, the internal wiring. That's why it is called hardwired. Hardwired. Wiring of logic circuit. Hence the name hardwire has come. What is the advantage? It can operate at very high speed. And the disadvantage is, since number of instructions or control lines is often in hundreds. So I told you here 256. The complexity of the control unit is very high and it incurs cost. It is very costly and difficult to design. So the control unit is inflexible because it is difficult to change the design. It is a hardwired design. You cannot oftenly change it. And you can see generating Z in. Z in is an instruction uh, at the time slot, the signal is asserted. T1 means the signal is asserted at the slot T1 for all instructions. Plus T6. T6 means what? During T6 for an add instruction. Add is asserted during the sixth time slot. During T4, the BR branch instruction is asserted, which is unconditional branch. So that you can see that those are the inputs of the AND gate. AND is asserted at the T6, branch is asserted at T4, T1 is at the all instructions. And when run is equals to 1, the counter is incremented by 1. At the end of every clock cycle, when run is equals to 0, the counter stops counting. After execution of each instruction, end signal is asserted, is generated. The end signal resets the step counter. The sequence of operations carried out by wiring of logic circuits, hence the name is called as hardwired. A complete processor is shown here. You can see what is there in the processor. You have integer unit. This processor to process the integer data, and you have floating point unit. Now you can see that there is a separate floating point. In order to handle the integer as well as floating point, you have separate two units, and the output and it is asserted. The data cache is asserted between this interface. So it is asserted between the processing unit and the main memory. The integer and the floating point unit gets data from the data cache. Instruction unit. It fetches the instructions from the instruction cache or from the main memory when desired instructions are not already in cache. Okay. So the processor, when cache is not there, definitely it has to go for the memory. The processor is connected to the system bus. System bus, it's nothing but your memory bus or external bus. Okay. Hence, to the rest of the computer by means of bus interface. Bus interface is a medium in order to interconnect the rest of the units. Using separate cache for instructions and data is common practice in a nowadays processor. Okay. The processor may include several units of each type to increase the potential for concurrent operations. So as I know, there is a separate integer unit, floating point unit in order to increase the concurrency. The 80486 processor has 8K bytes single cache for both instruction and data. Okay, whereas Pentium processor has two separate 8K bytes cache. So that means depends on the thing, the cache memory can always be upgraded. Excuse me, upgraded. Whereas the note you must note here is to execute instructions, the processor must have some means of generating control signals. There are two approaches which I already told you: hardware and hardware control and microprogram control. Thank you. This is the end of the session 4.